Hello everyone, welcome to the third video of the Python lesson. In this video, I'll demonstrating my Shapefile Validator program. So the program is designed to validate shapefile geometries, check for intersections, export validator, and convert shapefiles to CSV. So let's look at the structure of the program. In this, at first I'm going to explain the libraries I used. So the OS and sys library for path validation and file management, and pandas for data manipulation and exporting to CSV, and geopandas for reading and writing shapefiles. Last but not the least, using the shapely for geometry validation and intersection checks. So these libraries made the code efficient, readable, and suitable for handling real-world spatial data sets. Let's quickly jump into the class what I have did. So I encapsulated all functionality in a class called Shapefile Validator. So using a class helps me keep the code organized and modular. The constructor in it takes the shapefile path and validates it, loads it into a geodata frame, and prints some basic info like geometry types. And next, while looking onto the method 1, which is the validate geometries. So this is the option 1 which we can see in the menu. So this one checks whether each geometry in a shapefile is valid using the shapely is valid property. It returns true or false for each geometry. This helps me identify invalid polygons or lines like self-intersecting polygons. The next method is the check intersection. So in this method, I check if any geometries intersect each other. I only apply this to line string or polygon types because points usually don't intersect. I iterate through all pairs of geometries and print the pairs that intersect. Now next, moving on to the next method is the export valid geometries. So in this method, it removes all invalid geometries and exports only valid ones to a new shapefile. I filter using the self.gdf using the is valid and save the results with the to file option. This is how the export valid geometry option class works. And next one, moving on to the method, is the export non-intersecting. This method removes geometries that intersect with each other. I look through all the geometries in this section, and if a geometry intersects any other, I skip it. The remaining geometries are exported. Finally it shows the print option, exported non-intersecting geometries to output file. This is how it works. And the last one is the convert to CSV. So this method converts the point shapefiles to CSV. As I mentioned, it's a point shapefile to CSV. I extract the latitude and the longitude from the geometry.x and geometry.y and save them in a CSV format using the .to CSV. This is only applicable for points and a skip for other geometries. According to the assignment requirements, the program is like I have designed all of this. And finally it shows the method show menu, which shows the menu of the user to select what are the things to choose. Then that's pretty much. Then we can just quickly run the code here. So it's run. Now it asks for the enter path of the shapefile. So for this I have some example shapefiles in my folder to test it with. For example, I can give the bathymetry shapefile. So for this I need right click and copy path. We can also alternatively like copy using the shift alt C. With this I need to paste the path of the shapefile, which needs to end with .shp, or else we can just show how it works. Once it's done, it shows shapefile loaded successfully. After it's done, it allows the user to select an option like whether 1 validate geometries, or 2 to check intersection, and 3 remove invalid geometries and export. and 4 is remove intersecting geometries and export, and lastly convert shapefile to CSV, which only works on the points only, as I said. So now we can check by giving the validate geometries, like clicking option 1, and finally it shows the option validating the geometries whether it is true or no. Once it's done, according to the assignment requirements, the program executes the selected option once and exits automatically. So this design ensures clear single task execution. I can also show quickly. Here it's mentioned like after completing the selected operation, terminate the program. Menu option will not be reappear. This is how it needs to be. So yeah, it like terminated and menu option is not shown again. So in order to choose again, I need to rerun the program again. Shape validator run it, and again it asks for the path of the shapefile. So in this case we can choose the one without the shapefile option, like without the .shapefile. We can just delete the .shp and click. It shows the invalid shapefile path, as I said. So it looks for with the ending of .shp file. Yeah. So again it's like exited, so we need to run the program again by clicking the shapefile.py. For this case I am going to try with the invalid geometries and export valid. Like for this I have an invalid polygons showing. I can also show the invalid polygon shapefile how it looks. Yeah, so this is the invalid polygons I have to, yeah, so this is cross between a bow tie, looks like that. For this I'm gonna insert it for the invalid polygons not shape, copy path, and like insert the path here, and we click enter. The shapefile loaded successfully. For this we can just click the validate geometries option 1 and click. It shows the second one is false, which is invalid. So it correctly identifies the valid geometries and the invalid geometries. For this we can also check with the check intersection with the option 2. For this we need to run the file again and paste the invalid polygon shapefile again and check intersections option 2. Intersecting paths found. Finally it's showing the 0 1. So yeah, it's correctly identifying the intersection found. Maybe we can also test it with the correct one here, for like selecting the bathymetry shapefile. Click option check intersection. It shows all the list of intersections present inside the shapefile. This is how it looks. Yeah. Now let's move on with the remove invalid geometries and export. So for this option we need to rerun the Python code again, and for this we can import the invalid polygons.shape, and we can select the option 3, remove invalid geometries and export. So it asks for the output file name. Here for example we can give a valid.shapefile or something, like after making this into a valid one we can rename it however we like. So for example I can give same valid.shape. It shows the export valid geometries to valid, which I gave the same name. So once it's done, it creates a new folder naming the valid. So inside this folder we can able to see the shapefile present. This is how it works, and yeah. Now we can move on with the fourth option, remove intersecting geometries and export. So for this again we need to run the code and click the invalid polygon shapefile, and we can select the option 4, and how we name as, like for example non-int, we can put as non-int. It's just only the name, so you don't, if you want you can present it as .shp, or else you can just leave it as it is non-int and run. So in this it shows no non-intersecting geometries left to export. Yeah, so it like found two intersecting geometries, so no non-intersecting geometries left to export. This is how it expected to be work. It's everything working fine, I guess. So yeah, finally we can test it with the convert shapefile to CSV for the points only. So for this I have manually created a point shapefile. I can also show it in the QGIS. This is how it shows is in like 5 points here. So now I'll need to run the file again, and for this I will be giving the point shapefile copy path, and here we paste it. Yeah, for this it shows the geometry type as the point, and we can clearly give the option 5, choosing by 5, and click enter, and how the output file name should be look like, we can give the same as points and click enter. It shows like converted shapefile to CSV points, and once it's done it will create a file points. So when I click this, it shows the longitude and the latitude extracted from the point file as mentioned in the folder, like in the assignment task. It is how it works. Yeah, after, yeah, this is how they ought to be working. And the program includes checks for invalid shapefile path, unsupported geometry types, and empty shapefiles after removing the invalid or intersecting geometries. A clear console message for user guidance. This ensures the program doesn't crash and provides meaningful feedback. Yeah, this is pretty much how the Shapefile Validator works. Okay, then thank you all for watching. See you again in the next video. Don't forget to share, like and comment and subscribe. See you.